standing water.
My name's Jeff Sanders. I work with UVM Extension, the Northwest Crops and Soils team. And today we're out in Irisburg, up in Orleans County, and we're doing some work on a farm. And we're talking about doing no-till or reduced-till corn planting today. And we're working with UVM Extension's 7200 corn planter. It's an older corn planter. It's a 1998 model planter that UVM Extension, we acquired this through a CIG grant many years ago when we were doing a large cover crop project, and we continue to use this to do demonstrations and trials. Later today we'll be putting in a neonic trial with it. We're going to talk a little bit about how you can get the most money out of an older planter. This planter was acquired for something like $12,000 out of the Midwest many years ago, and we've added some upgrades to it, and I'm just going to talk a little bit about those upgrades that should keep you doing no-till on a budget, if you will. And there's different degrees to which you can go with the upgrades, and I'll just look at a row unit. We have this end row unit. So this is what plants the corn. And really, if you wanted to do no-till, the key ingredients to put that system together is a row cleaner in the front, and this is a Dawn row cleaner, but Martin Till makes them, many different manufacturers, and this just separates the residue from in front of the disc opener. And the second thing that you would need, I would recommend, is getting heavy duty 3.5 millimeter disc openers. A normal planter would have 3 millimeter, and they will flex on the rocks and flex in the hard soil. A 3.5 millimeter is much stiffer, and it'll penetrate the soil much better, and so I would recommend that. This planter comes with, I think they're mud slinger gauge wheels. They're open so they don't plug up with mud as well. The planter, these row units came with this. These are not the original row units. In Midwest, everybody's going to high-speed planters, so they're retooling their toolbar. And if you look around on the internet, you'll find a lot of good row units out in the West that are cheap. I think we acquired these row units for $500 a piece, and the reason why we bought them was because with the down pressure system that we run, a hydraulic down pressure, it puts a lot of force on the row unit. And the original row units that came with the 7200, the MaxiMerge 2, were just pressed steel. And these new ones, which I think are, I forget the version of them, but they're cast steel, so they don't bend. The other ones were bending in hard soil conditions, and these don't bend. They stay the way they're supposed to. So we made that upgrade. And the last thing that you really need is a good closing wheel system. So the idea with no-till is all we're doing is we're opening a trench in the soil, we're placing a seed, and we're closing the trench. And the key to success for that is to do that very consistency across a wide variety of soil conditions and across all the rows on the planter. So this planter has a lot of additional things. One of the things that's very important is a down pressure system. This is hydraulic, but you could do it much cheaper with just heavy duty down pressure springs, which you can acquire online or through whatever your vendor is. This happens to be an Ag Leader system, we like hydraulic down pressure because it reacts to the soil conditions in really in real time, where a pneumatic system takes time to build pressure, to push down, and also to release pressure. So it's always catching up to the changing soil conditions, where a hydraulic system's immediate. And a spring system also works, because really you just need to make sure that your gauge wheels are staying fully engaged in the soil so that you're planting at a consistent depth. So a couple more things about this planter is we do run an ag leader, seed monitoring and fertilizer system on it. And if we come around to the front, you can see there's a bunch of control modules set up. So the way on the right is the fertilizer pump that pumps it into all the distributes across all the rows, 12 distributors. And then the thing in the center is the power. That's where the power distribution is. This planter is run with electric drives. It's not that you need electric drives. You can run them on chain drive, that's fine. Millions and billions of acres get planted with chain drive planters over the years. The electric drives give us more flexibility. We can vary the rate row by row, and it's much easier to control the population from the cab. We don't have to change gearboxes, chain setups and sprockets. You just hit a button and changes. It's really a matter of convenience. We found that they've been very durable, the electric drives. The only issue that we've seen is if you have alternator problems on the tractor, if your voltage drops, you will very quickly burn the motors out. They need full voltage to operate. So that's the power distribution. The 3 boxes in a row control the liquid fertilizer. So another feature of this planter is it has swath control. So if we've already been over it with seed and fertilizer, or seed or fertilizer, the rows will shut off so that you aren't planting double. So if you've planted and then you drive right back over it, it won't plant. The planter just shuts off each individual row. So that way you're not wasting seed as far as that goes. And the last controller is it's called a DC motor controller. That just is running that pump over there. So I think if you do have technology on your planter, it's important to understand what the components are doing, so when they fail, you have an idea about where to look. We just got off the planter moments ago. The computer said that one row wasn't planting, and in 5 minutes we found a wiring problem, and we fixed it, and we should be good to go now. So just understanding where to look for issues. As these systems get older, they will electrical issues will creep in. Mice chew wires get chafed. It's a fairly harsh environment. So I think all of this is attainable. The system's attainable. I just spoke about a bunch of bells and whistles that are nice but aren't needed for a small farmer to get into it. I think before a small farmer does get into no-till, they need to understand how they're going to deal with things like compaction, how they're going to deal with the residue on the fields, how they're going to handle manure applications, if they're just going to surface broadcast or if they're going to inject the manure, and how we manage those nutrients, because if we're not going to manage them properly, we may not keep them out of the water, which is what kind of the goal is. So all that to say, it's more of a system approach. It's not just a practice that you do irrespective of everything else that you do. You kind of have to look at the big picture and align all your practices into the no-till system. And people modify the system. They do scratch till, which is basically what we have here. They spread manure, lightly harrowed it, and now we're planting into it. And people do injection, all kinds of different things. Every farm is different about what you have to use, what you have at your disposal. But I wouldn't say that no-till is unattainable to any farmer. And I will also say that no-till doesn't work on every field. There's certain conditions that just aren't conducive to profitable no-till farming. Some people will tell you different than that, but I'm thinking about it pretty practically. Heavy clay soil needs to be managed pretty carefully. No-till does work on it in certain circumstances, doesn't work in others. Super stony soil, sometimes no-till is the answer to that because you're not tilling. Sometimes it can be a problem because the rocks will create issues with the planter. So, and you're not picking the stones if you're not tilling. So anyways, that's some pointers about how to do a no-till here in northern Vermont.